Hi, my name is Hanna and I will give an introduction to this activity. As we learned in the course, Isaac Newton was an English physicist, mathematician, inventor, and philosopher. He invented the fundamental laws of mechanics and their proper mathematical formulas. Newtonian mechanics, also known as classical mechanics, is a branch of physics that studies the forces that causes movement or the absence of it in macroscopical bodies or even planetary systems. In this video, my friends will explain the laws that rule motion, and we will also play a game to ensure our knowledge.
Hi! Today I'm going to explain to you Newton's first law of motion, also called inertial law. This law basically says that if an object is in rest, it will stay in rest unless an external force changes it and makes it move. And it also says that if an object is in motion, it will remain at the same velocity unless an external force changes its velocity. It could be by increasing it or by decreasing it or stopping it at all. Today I'm gonna test Newton's first law of motion, which is inertia. Here we have an object in rest, and if I put some force on it, we can see it will move. By now, it doesn't have any force affecting it, so it doesn't move as you can see. But if I apply some force, it will move like this, and there is another external force which made its velocity change like this. It went from this to that. It stopped, as you can see, so its velocity changed.
Newton's second law of motion, or also called law of force and acceleration, dictates that the acquired acceleration of a body is directly proportional to its net force and inversely proportional to its mass. This also means that force is equal to the change in momentum per change in time. This law can be represented by the formula force equals mass times acceleration. We can observe this law in our daily lives, for example, when pushing an object. Its acceleration will depend on the force that I will exert, which may be greater or lower depending on the mass of the lawnmower.
Hey guys, I'm gonna explain the Newton's law, action and reaction. It's the third law. Newton once said, to each action, an equal reaction is always opposed, but in the opposite direction. For example, when a body exerts force to another object, this will be the action. These objects will react to the opposite direction. That will be the reaction. Like with the same intensity and direction, but opposite direction, okay? Opposite. For example, a rocket. The action will be the fire in here, that it's going downwards. And the reaction is going to be the rocket going upwards, okay? The same intensity, but opposite directions. As you can see, this third law allows us to understand what happens when two bodies interact with each other. It states that when one body applies a force to another, it reacts by exerting on it a force with equal value and direction, but with the opposite direction, okay? As I said before, logically this third law applies that to all the objects that we touch, pull or push like each other are obviously affected by forces that occur simultaneously in pairs. Both. This pair of forces is known as action and reaction. Pretty simple, right? Yeah. If you want to understand better this law, this third law, you are gonna watch now this experiment that I did from myself. So I hope you like. Hey guys, welcome back to my channel. My name is Valeria, and now I'm gonna do the experiment of the third law of Newton. The ingredients you will need will be a balloon, straw, thread, and washi tapes. The thread needs to be attached to 2 points like this, like this, and the straw needs to be in the middle of it, like this. You have to blow your balloon like this, You have to paste the balloon to the straw like this with the tape, masking tape, or washi tape can be, and let it be like this. So you are wondering what happened in the experiment. As you could see, the balloon shot out along the tight thread. All the air that was inside the balloon went through that direction, like this direction. This one. Causing the balloon to go to the opposite direction, being a clearly example of the law of action-reaction. Because the action was the air going to one direction and the reaction was the balloon going to the other direction.
Hi.
Hi, we are 2007 and I am Diana.
I am Valeria.
I'm Gabriel.
I'm Hanna.
And we are going to play this game.
Yay!
Activity number 8.
I feel like a gamer.
So, first luck.
Number 1.
Nació en Inglaterra. Fue uno de los científicos más brillantes que ha tenido el mundo, quien formuló las leyes fundamentales de la mecánica, así como la ley de la gravitación universal. Para sus formulaciones tuvo que inventar métodos matemáticos de cálculo y otro más de sus trabajos científicos fue el descubrimiento del espectro de colores de la luz blanca, cuando pasa por un prisma. The answer, I think, is Isaac Newton.
Yeah, Isaac Newton. I think that too.
Okay, let's check. Okay.
Yay!
Now it's turn of Gabriel.
Yep. Gabriel, it's your turn.
Thank you. Oh, it's one triangle divided into 2, so it will be 3 triangles.
Perfect. I agree with Gabriel.
I agree with Gabriel too.
Yeah.
Number 3 is turn for Valeria.
Es una cantidad física vectorial que mide la intensidad de la interacción entre dos o más objetos. Esta interacción puede ser por contacto o a distancia. I think it's fuerza. Force. But let's put it in Spanish because it's in Spanish.
Yeah,
so
it's in Spanish.
it's a little bit special. Game.
Fine, it was correct. Back, next time for Hanna.
Es la cantidad de materia que posee un cuerpo y también se puede definir como la cantidad física escalar que mide la resistencia que presenta un objeto para que adquiera movimiento, o bien para modificar su condición de movimiento, cambio de velocidad. I think it's mass. In Spanish it would be masa.
Fine, let's...
Yeah, I agree with Hanna because she's God.
Yeah, fine.
Yay!
Okay, now it's my turn again, so let's go. ¿Cuántas leyes de Newton existen? They are 3.
Yeah, 3.
3.
We saw that in class.
Correct. Fine. Turn for Gabriel.
La primera ley de Newton, that's the law of inertia. In Spanish it will be inertia.
Inertia, yeah.
No, sí.
Yeah. Valeria.
La segunda ley de Newton se encarga de cuantificar la fuerza. Force. I'm sure about that. I'm actually sure about that.
Okay, I don't know, but let's check.
Oh my god. Oh my god.
Yeah!
Yay!
Fine. Now that one. Hanna.
¿Cuál es la tercera ley de Newton? It's action and reaction. In Spanish it will be acción y reacción.
Yep.
Okay.
Yay!
Yay! We got all the luck. So thank you for watching and bye-bye.
Thank you for watching. Don't forget to subscribe to our channel and put 100 as a as the final grade. Thank you.
Bye-bye.
Have a nice day. We love you.
Time for conclusion. So, in this activity, we learned about the three Newton laws: the inertial law, the force law, and the action and reaction law, that are very important for comprehend how the world functions, and specifically to know and analyze the forces that act on all the objects and even ourselves. They're also important to comprehend machines and create more complex ones, and to understand the planetary movement. It results very fascinating how Newton laws are present in everyday life. The inertial law, for example, is present when we use the brakes of our vehicles and we feel like something is pushing us forward, or when we accelerate them and we feel like something is pushing us backwards. The force law is present, for example, when we want to accelerate our bikes and we need to apply more force with our legs to the pedals for it to move faster, or in the fact that it's easier to push an empty supermarket cart than a full supermarket car, because the full one has more mass, so it requires more force. And finally, the action and reaction law is present, for example, when we want to swim underwater and we are using our arms and we are moving them backwards, but the water pushes us forwards. And well, finally, as a team, we had a lot of fun in this activity, and we also learned a lot and we enjoyed it.